Welcome to qnawire.
In this problem, we are given the velocity, the mass, and some force pushing up against a person on a rotor ride, and we have to find the radius of that ride. So figuring out what this force that we're given of 560 newtons actually is becomes way easier than when we draw a free body diagram like I've done on the left here. So we can see that the force, if the red dot is the person, then we know that the force of gravity is always pointing down, right? But the normal force in this case is actually not opposing the force of gravity, right? Because the normal force always points perpendicular to whatever surface something is resting on. So it's pointing towards the center of the circle, as you can see here. Now, there's also a frictional force, which is counteracting gravity, and that is caused by whatever surface we're on, but that's actually not important to this problem. So the force that is described to us in the problem is pushing up against a person's back. So considering the way that the normal force is pointing, that must be our 560 newtons. And so that force, wrong pen, must also be equal to our centripetal force, since that is the force that's always pointing towards the center of circular motion. And we know that the equation for the centripetal force is mv squared over r. Now, if we want to, let me remember to write that is 560 newtons. Now, if we want to solve for r, all we have to do is rearrange. We get r is mv squared over 560n. Now, when we plug in our quantities from earlier, our n is equal to 83 kilograms, and our v is 3.2 meters per second, and that's all over 560n. Now, we're going to find that r is equal to 1.518. And when we check out our units, we have to remember that a newton is equal to kilograms times meters per second squared. I just realized that up here, I forgot to square my velocity. Right here, don't forget to do that. When we do square it, the 1.518 is our result. But that squared is also important for our units because remember, a newton is equal to kilograms times meters per second squared. So our units cancel out to give us a result of just meters, which of course makes sense since we're calculating a radius. And that is going to be our final answer.